T minus 45 seconds. Throughout human history, wars have existed. We have fought over resources and territory, whether it be with sticks and stones, bows and arrows, or guns and ammunition. But people are the ones who fight, and the deadliest wars have ended the most lives. With some wars, they're claiming huge amounts of lives. But let it be that through war, people tend to change, as through the war we have gotten many scientific achievements, with some deadlier than others. But let's be reminded that even if you count down from 10, a peace can only be achieved for war, and that if we choose to fight more wars, then we kill less people than last time. (79 AD). Sub-Atomo, the Roman Empire. In the wall of this veld we can find a glass mosaic with a 1% uranium oxide. The element was used as a colorant for the glass, but while this was over 2 millennia ago, over 1 millennia ago, a 9th century Chinese alchemist would attempt to create an elixir for immortality. But when mixing 75 parts saltpeter, 15 parts charcoal, and 10 parts sulfur, he found that when it was exposed to fire, it would explode and burn his house down.
2006, Microsoft says, get the hell out of here with that resistance game, nobody wants that.
Fire-spurting lances were used during the Green Sun Wars in the 10th century. These are known as the first guns we know of. The weapon consisted of a bamboo or metal rod to hold the gunpowder. However, the Chinese didn't want anyone else to have this weapon, so they banned the sale of saltpeter to foreigners in 1076. However, the knowledge of this element, gunpowder, would spread through the Silk Road to Europe.
2007, they pull out the big gun. Sony is sitting there with stupid Uncharted 1. Blah.
The cannon became very popular. It didn't matter if you had horses. The cannon could shoot more powerful shots than your arrows could, and even the toughest of swordsmen with the strongest armor would still get blown away. The first known handheld gun, the hand cannon, was made of 2 parts. The first part was the long barrel to hold the projectile, and the second part was a pole that the gun wielder would hold. And to fire it, a flame at the end of the barrel was held by the wielder or an assistant. However, since ammunition was rare in the 13th century, nails, stones, and other objects were shot out. The weapon was slow to reload, not very accurate, and bulky. But in the 15th century, the matchlock was designed. It was an S-shaped arm that had a trigger, and lowered the match to ignite the gunpowder. It made guns smaller. However, in the 16th century, spiral grooves were cut on the inside of the barrel of the guns. This made guns more accurate as the bullet obtained a spin when being shot out. On another note, the flintlock was invented in the early 17th century and made reloading faster. Flintlocks were also used on muskets. And by the time the American Revolution happened, the soldiers were able to fire over a whopping 3 times a minute.
2008, Xbox says, ha! Too human! Oops, I mean Gears of War 2, but then Sony says, ever heard of a game called Metal Gear 4? Get that bullshit out of my face.
1836. Samuel Colt invents the Colt Patterson. While the gun wasn't the first revolver, it was the first commercially viable one. The revolver had a cylinder where 5 bullets could be inserted, and was able to shoot multiple bullets before being reloaded. Another feature of the Colt Patterson was interchangeable parts. This lowered the cost of servicing weaponry when parts of the weapon were broken. One day, however, likely in 1846 or 1847, Samuel Walker would approach Samuel Colt for a contract of 1,000 revolvers to be used in the Mexican-American War. However, the Colt Patterson had to be redesigned to fit Walker's specifications. Samuel Colt had met the specifications, and the Colt Walker surpassed other revolvers of its time. The gun weighed around 2 kilograms and was 39 centimeters long. This allowed the gun to have 44 caliber bullets instead of 36 caliber. The gun was also a 6-shooter instead of a 5-shooter. But one of the best additions to the Colt Walker was a front sight, allowing the gun wielder to aim more accurately. 1861, the American Civil War had begun. Richard Jordan Gatling visited dead and wounded soldiers at the beginning of the war. However, when he examined the soldiers, he found something peculiar. Only 3 out of every 18 soldiers died from bullet wounds. The other 15 died from illness. So Richard Gatling developed a weapon that was able to shoot more bullets so that fewer men were needed to fight wars and smaller concentrations of men would be needed, cutting down how many men would die from illness in combat. The gun was tested and patented in 1862, with an improved model patented in 1865. The Gatling gun used a hand crank to shoot and was able to shoot over 200 rounds per minute. And while it wasn't the first machine gun, it was the first gun to solve the problem of reloading, reliability, and a sustained rate of fire. But the Gatling gun was also meant to act as a form of deterrence, to have a gun so powerful that it would discourage people from going to war altogether.
2009, Xbox is like, Halo Wars.
1882, an American who Hiram Maxim knew told him to hang up chemistry and electricity. If you want to make a pile of money, invent something that would enable these Europeans to cut each other's throats with greater facility. 3 years later, the Maxim gun was invented. It was a unique weapon. While other machine guns at the time used air cooling, the Maxim gun used water cooling, which allowed the gun to be fired for much longer. The Maxim gun, however, was initially used to slaughter colonial enemies, and it was so good at it, so good in fact that in 1900, Queen Victoria bestowed a knighthood on Hiram Maxim.
2009, Xbox is like, Halo Wars. That's when Sony goes, Halo Wars? Are you being serious out here? Stand back, everybody. I'm about to end this company's whole career. Boom!
While uranium oxide was already used as a colorant for a glass, in 1789, pitchblende was extracted from the Habsburg mines in Bohemia. German chemist Martin Klaproth would dissolve it in nitric acid. Discovering uranium. The uranium element was used as a colorant for glass, and was quite popular due to its glow. The amount of radiation emitted by the glass was smaller than that of a banana, making it safe to use. But with extraction processes getting refined in the 1840s, the glow of green uranium glass would become even more popular. Popular enough to have Antoine Henri Becquerel in 1896 accidentally leave a sample of uranium on top of an unexposed photographic plate. He had found the photographic plate to be fogged and deduced that uranium emits invincible rays. 1897, J.J. Thomson would expose cathode rays to electrically positive and negative samples, and he would notice that the rays deflected depending on the sign of the charge exposed to the tube. He had discovered the electron. 1898, the husband-wife team of Marie and Pierre Curie began researching on radioactivity, discovering the elements of radium and polonium. 1899, Harriet Brooks would discover that thorium gave out a radioactive gas with a smaller molecular weight than that of the original thorium. September 27, 1905, Albert Einstein would submit a seminal paper with his famous E equals mc squared equation. Energy equals mass times the speed of light squared. Einstein showed with this theoretical equation that mass and energy aren't independent and can be converted to one another. The equation became a tool for predicting how much energy a nucleus stores, allowing physicists to predict the energy released by a nucleus when being split. In 1911, after naming and classifying alpha, beta, and gamma radiation, Ernest Rutherford would discover that the mass of an atom is concentrated mainly in the nucleus. He also experimented with a gold foil, passing alpha particles through a thin gold sheet and noticing their deflection patterns. He concluded that the nucleus of an atom is positively charged. 1919, Rutherford would perform the first artificial nuclear reaction, proving that bombarding nitrogen gas with alpha particles results in an occasional collision, creating an oxygen isotope. 1932, James Chadwick would discover the neutron. This made it easier to split a nucleus, as neutrons are neutrally charged and can penetrate into a nucleus. 1934, after discovering that slower neutrons were captured more easily than fast ones, Enrico Fermi would bombard many different elements with slow neutrons. Fermi did expect that neutron bombardment of uranium would create an element with atomic number 93, but since there was a reaction to this element that wasn't observed, and since Fermi didn't understand the effect of neutron bombardment on uranium, this would become known as the uranium problem. In the same year of 1934, Irene and Frederick Curie would discover artificial radioactivity by bombarding boron with alpha particles. The boron broke down into nitrogen-13 and a neutron, and the nitrogen-13 broke down into carbon-13, with that carbon-13 being the first radioactive element created artificially. 1939, Otto Robert Frisch would observe nuclear fission using an ionization chamber to detect fragments from fission. With uranium-235, a nuclear fission reaction can produce 2 or 3 neutrons along with fission products. Bombarding the neutrons can create a chain reaction if at least 1 neutron from each fission process strikes another U-235 nucleus, using the minimum amount of fissionable material. Leo Szilard described this concept as the critical mass. But maybe we just need to look a little bit closer at our solar system.
Hello there, I'm Sub-Atomo. And for us to understand the atom, we need to go back to ancient Greece, where the philosophers, mainly Democritus, believed that all matter in the universe was composed of fundamental, unchangeable, and indivisible objects called atomos, which meant indivisible. There were attempts to find a philosopher's stone, prove the Greeks were wrong, and make a lot of money, but for a long time these attempts failed. In fact, John Dalton would suggest a solid sphere model in 1803. That would state the same thing, except that atoms of a certain element are identical, with compounds being combinations of different types of atoms. But in 1904, J.J. Thomson would suggest the plum pudding model of the atom. He suggested that atoms are composed of electrons scattered throughout a spherical cloud of positive charge. However, Ernest Rutherford would suggest the nuclear model in 1911. The nucleus of the atom would have positive energy concentrated into it and have the electrons orbit the nucleus. It is good to consider how our solar system looks, because in 1913, Niels Bohr would suggest a planetary model of the atom, stating that the electrons moved around the nucleus in orbits. But as far as we know, an atom truly looks like this. This is the quantum model, created by Erwin Schrödinger in 1926. He stated that electrons don't move in a fixed path, and that it's impossible to know the exact location of an electron. He also suggested the clouds of probability, stating that electrons just had spots where they were more likely to be. But if you want to know about the radioactivity in Japan, we'll have to go back 26 years to 1900, where Hantoro Nagaoka would attend the first International Congress of Physics in Paris, where he heard Marie Curie's lecture on radioactivity. In late 1903, Nagaoka would develop an atomic model. It looks like the planet of Saturn and assumes that the nucleus is a positively charged sphere encircled by negatively charged electrons. In fact, Ernest Rutherford referred to Nagaoka's model in his 1911 publication of his gold foil experiment. But in 1934, Tadaoshi Higasaka would publish his atomic physics theory and the idea of shell-like structures of nuclei, pointing out that atomic nuclei had huge energy potential that could be used for weapons. What? However, the story of plutonium is far different, as Enrico Fermi would discover in 1934 that neutron irradiation of uranium leads to a number of radioactive substances. And in early 1939, Hahn and Strassmann would describe experiments which make it certain that radioactive isotopes of light elements like barium were due to neutron bombardment of uranium. That same year, Macmillan at the University of California would measure the energy of two main fission fragments by observing the distance they traveled from each other. However, there was another radioactive product of their reaction with a half-life of 2.3 days which didn't recoil. He thought that this product was formed by a neutron capture because that process doesn't release much energy. But in the spring of 1940, Macmillan with Abelson deduced that this product was an isotope of element 93. Formed from beta decay of uranium-239, which has a half-life of 23 minutes. Element 93 was then named Neptunimus because it's beyond uranium, just like how the planet Neptune is beyond Uranus. But on December 14, 1940, Glenn Seaborg with a group of scientists would bombard uranium oxide using 16 mega-electron volt deuterons from a 60-inch cyclotron. Alpha particle radioactivity grew into separated element 93 fraction, and over the following weeks, the alpha particle was chemically separated from neighboring elements. The element 94 was positively identified and was found to have two oxidation states, with the first successful oxidation of element 94 occurring on the night of February 24th. The isotope identified had a mass number of 238 and a half-life of 88 years. However, experiments continued throughout 1941 and element 94 didn't have a name, so it was codenamed copper, but there was a problem. The group started using real copper in their experiments, so they still called element 94 copper, but the real copper, honest-to-God copper. So Glenn Seaborg named element 94 plutonium because just like how neptunium is beyond uranium, Pluto is the second planet beyond Uranus, and in the spring of 1941, things would get more nuclear with the identification of plutonium-239.
...2006, Microsoft says, get the hell out of here with that resistance game. Nobody wants that. 2007, they pull out the big guns. Sony is sitting there with stupid Uncharted 1. 2008, Xbox says, ha! Too human. Oops. I mean, Gears of War 2, but then Sony says, ever heard of a game called Metal Gear 4? Get that bullshit out of my face. 2009, Xbox is like, Halo Wars. That's when Sony goes, Halo Wars? Are you being serious out here? Stand back, everybody. I'm about to end this company's whole career. Boom.
In 1863, a German chemist by the name of Julius Wilbrandt created trinitrodoluene to be used as a yellow dye. While it was known to be explosive, it was hard to detonate compared to alternatives at the time. However, in 1902, the German military started filling artillery shells and armor-piercing rounds with TNT, so that they would explode inside the British armor, whereas other explosives at the time exploded upon impact, meaning the explosion would occur outside the armor instead of insight. Explosives and weapons are good enough, but there were fears that Adolf Hitler would develop his own nuclear weapon, so August 2nd, 1939, Albert Einstein, Leo Szilard, and Edward Teller decided to compose a letter to Franklin D. Roosevelt, stating that work by Enrico Fermi and Leo Szilard had made Einstein believe that uranium could be an important source of energy. That more work from Fermi and Szilard had made it possible to set up a nuclear chain reaction in a large mass of uranium, creating lots of power, and most importantly, that this discovery could create extremely powerful bombs. They could be too heavy to be transported by air, but if carried by a boat and if they exploded in a port, it wouldn't just destroy the port, but also the surrounding territory. The letter also shows the fear of the three scientists when writing it, stating that Germany has stopped the sale of uranium from the Czechoslovakian mines, and that the Kaiser Wilhelm Institute in Berlin was attempting to repeat American work on uranium. But it would be the economist Alexander Sachs that would deliver the letter to FDR, and after reading the letter, FDR said, "This requires action." General Leslie Groves had finished the construction of the Pentagon, but when he was waiting for a combat assignment overseas, his superior officer told him that the Secretary of War had selected him for an important assignment in Washington. Groves was then appointed as the head of the Manhattan Project. October 1942. Work on the Manhattan Project was quite slow, and when General Groves came to the University of Chicago for an inspection tour, Robert Oppenheimer discussed with him the need for a central facility. It would need to be at least 300 kilometers from a coastline or international boundary for safety from attack. It had to be in a remote or sparsely populated locale, room for explosive testing with weather good enough for construction to proceed year-round, and enough housing to immediately accommodate the first group of scientists. Major John Dudley found a location in Oak City in south-central Utah, but there were too many residents and too much farmland that would need to be evicted. So Oppenheimer and Groves drove down to Jemez Springs, New Mexico to see the area, but they both came to the same conclusion, that the canyon walls were too deep for comfort, space, and security. However, Oppenheimer remembered a boys' school in New Mexico, so Groves and Oppenheimer drove down there together. When they came there, General Groves said, "This is it." December 4th, 1942. The school received a notice from Henry Stimson, the Secretary of War, that the school is being taken over and that all records of the acquisition will be sealed from public view. And with the final graduation of the school happening in February 1943, Los Alamos, New Mexico was chosen as the test site for the Manhattan Project. December 1942. At the University of Chicago, Enrico Fermi would successfully create a controlled chain reaction, but since the research had to be disguised, it was called the M.A.D. lab. Chicago Pile 1, or CP1, was the first nuclear reactor and was made up of big piles of graphite and uranium blocks. The power produced, however, was a small amount of plutonium-239, but it proved nuclear fission to be possible. The Los Alamos site designed two types of bombs. One was a gun-type bomb with uranium-235, where a controlled explosion on one end of the bomb drove one piece of the uranium to the other side, creating the critical mass. The other bomb was an implosion-type bomb with plutonium-239, where the plutonium would be compressed like a tomato and form the critical mass. However, while the scientists at Los Alamos were building a bomb, World War II was still going on, and by February of 1945, it was clear that the Germans were losing the war in Europe. So, the British Prime Minister, Winston Churchill, American President Franklin D. Roosevelt, and Soviet Premier Joseph Stalin met at Yalta in the Ukraine to plan on what would happen to Europe after Germany's defeat. Because the common danger of Adolf Hitler's Germany united the Big Three, they actually got along quite well and agreed on a lot of issues. Stalin had agreed to enter the war against Japan once Germany surrendered. The Big Three all agreed that liberated countries should be allowed to hold free elections, that Germany should be divided into 4 zones, French, American, British, and Soviet, agreed to join the United Nations, agreed to hunt down war criminals, and that Eastern Europe should be a Soviet sphere of influence. However, they disagreed on Poland, with Stalin wanting territory from Poland and saying that Poland's border should move westwards into Germany. Churchill and Roosevelt didn't like this, but Churchill convinced Roosevelt to accept it as long as the USSR agreed to not interfere in Greece, where the British were preventing a communist takeover. Stalin accepted it. But where were the Japanese with nuclear physics at this point in time then? Well, the Japanese Prime Minister, Hideki Tojo, gave orders to build an atomic bomb during World War II. But a major problem was a lack of uranium in Japan. So one of the scientists working on the project, Yoshio Nishina, asked the officers for 2 tons of uranium ores. The army then sent out a telegram to the Japanese ambassador in Berlin to request uranium from Germany. Hitler agreed to help and send a German submarine carrying 2 tons of uranium. The problem was that the submarine was sunk by either the Soviets, British, or Americans, so the uranium never made it to Japan. On another note, Yoshio Nishina was asked by the Japanese army to focus his research on nuclear fission, but after failing to extract meaningful amounts of uranium-235, he announced the end of his project at a meeting in Riken on May 15, 1945, concluding that extracting uranium-235 was impossible and that the Americans had the same problem. This stopped atomic bomb-related research in Japan. However, one day in the New Mexico desert at night, humanity would say to the world, Ezekiel 25:17. The path of the righteous man is beset on all sides by the iniquities of the selfish and the tyranny of evil men. Blessed is he who in the name of charity and goodwill shepherds the weak through the valley of darkness, for he is truly his brother's keeper and the finder of lost children. And I will strike down upon thee with great vengeance and furious anger those who attempt to poison and destroy my brothers, and you will know my name is the Lord when I lay my vengeance upon thee. 5:29 a.m. Mountain Wartime, July 16th, 1945. The gadget went off. A plutonium implosion type bomb. Several scientists started a betting pool on how big the explosion would be. The majority of the bets were very low and estimated the explosion to be less than 10 kilotons of TNT. The yield was 25 kilotons of TNT. The mushroom cloud was seen over 150 kilometers away. In the words of the man, Robert Oppenheimer himself, now I am become death.
The destroyer of worlds.
The story of the atomic bomb was just about to begin. As a day after the Trinity test, the Potsdam Conference would begin on July 17th. After Hitler killed himself, when the Allied troops reached Berlin, the war in Europe was won, and a second conference would take place in Berlin's suburb of Potsdam. But a number of changes had taken place since Yalta, including the death of President Roosevelt on April 12th, who was replaced by then Vice President Harry Truman, who was more aggressive towards communism. And at the beginning of the conference, Truman told Stalin about the atomic bomb, but Stalin wasn't surprised, as he had spies from the Manhattan Project who told him. Eastern Europe was also liberated from the Germans by the Soviets, but instead of taking them home, Stalin left his soldiers there, and refugees fled in fear of a communist takeover. With a final change occurring during the conference, as in late July, Britain had an election, and Winston Churchill was replaced by Clement Attlee. Potsdam had more disagreements than in Yalta. For example, Stalin wanted to cripple Germany completely, protect the USSR, but Truman didn't want to repeat the mistake of the Treaty of Versailles. Stalin also wanted compensation from Germany, but Truman once again didn't want to repeat the Versailles. And when Stalin said, "If the Slavic people are united, no one will dare move a finger against them," Truman became rather unhappy about Stalin's intentions. However, the war in Japan was still going on. But on August 6th, just after 8 a.m., a little boy would be dropped on Hiroshima. The entire city was engulfed in flames. Over 75,000 people died immediately, or sometime later due to radiation poisoning. Nagasaki would meet the same fate with the Fat Man on August 9th. Luckily for the Japanese, World War II would end on August 15th. But unluckily, the Japanese had to surrender. The Japanese were lucky for the reason that a third atomic bomb was supposed to be dropped. But instead, the plutonium core meant for the bomb would demonically take the lives of 2 men instead of thousands. It is worth noting that Yoshio Nishina joined a team of scientists to evaluate the impact of the bomb dropped on Hiroshima. Nishina found out that the bomb dropped was an atomic one, and that the Americans had built an atomic bomb, and considered committing suicide when he found out he was wrong. Furthermore, The Allied Occupation Forces General Headquarters, or GHQ, destroyed all 4 cyclotrons in Japan. The news shocked American physicists, including Irving Langmuir, who, at the United States Senate, said, "You can't gain atomic bombs from cyclotrons. You gain knowledge." In 1944, the Nazis retreated from Greece after the monarchists and communists united to fight a common enemy. But when the common enemy was gone, the 2 groups would become rivals, and a civil war would start in Greece, with the communists wanting a Soviet republic and the monarchists the king to return. And so Winston Churchill sent British troops to Greece in 1945 to restore order and supervise free elections. Being British, Churchill obviously supported monarchists and the king to return to power. The British were successful, and the king returned to power. But in 1946, the USSR protested to the UN that British troops were threatening peace in Greece. When the UN didn't take action, the communists tried to take control of Greece by force, and another civil war developed. However, the British couldn't afford the cost of war, and announced on February 24, 1947, that they were withdrawing their troops. Luckily, Harry Truman stepped in, and paid for it by the Americans. British troops stayed in Greece and propped up the king's government. This would pave the way for a diplomatic war that had to remain as cold as possible. As on March 12, 1947, President Harry Truman would give a speech to Congress declaring the Truman Doctrine, stating that the United States of America would provide political, military, and economical assistance to countries under threat of external or internal authoritarian forces. The Cold War had begun.
Now, the atomic bomb is considered to be the worst invention ever made by some people, while others see it as one of humanity's greatest achievements. And for many reasons. It could end all life on Earth if it were to fall in the wrong hands, but at the same time, could be our only way of preserving peace. For example, during the Cuban Missile Crisis in 1962, the world came the closest it ever was up to that point to mutually assured destruction. This is important because after the failed Bay of Pigs invasion in April of 1961, the Soviet Union started arming Cuba. And while the Soviets assured the Americans that Cuba would never receive nuclear weapons, an American U-2 spy plane took photos of a missile site in Cuba on October 14, 1962, with the missile sites being able to send a nuclear bomb to almost every part of America. This then made the US President, John F. Kennedy, and his advisors come up with a plan to deal with the missiles in Cuba. It is also important to note that both the Americans and Soviets had to be very careful to not escalate the crisis too much, because the total nuclear stockpile at the time was around 30,000 nuclear bombs. And if any side made a wrong move, it would have been very likely that the entire world would have ended due to mutually assured destruction. This demonstrates that the atomic bomb was a bad invention, because if something like the Cuban Missile Crisis were to happen again, and the wrong people were to have control over the nukes, humanity would likely cease to exist. However, the fear of mutually assured destruction and repeating the Cuban Missile Crisis had forced both the Americans and the Soviets to take steps to avoid nuclear war. This is important because when the Cuban Missile Crisis ended on October 29, 1962, the Americans agreed to remove their nuclear missiles from Turkey, and the Soviets agreed to remove their missiles from Cuba. The Americans and Soviets also set up a permanent hotline between the White House and the Kremlin, allowing the American and Soviet governments to have better lines of communications, especially during any conflicts. And in 1963, the Americans and the Soviets signed a limited test ban treaty, banning all nuclear tests in the atmosphere, space, and underwater. This demonstrates how the atomic bomb is a good invention, with the fear of ending the world under mutually assured destruction forcing the nuclear powers to make compromises and preserve peace. Furthermore, the space race would have never happened without the atomic bomb. This is important as the space race was a technological conflict between the US and the USSR, and a conflict that would have never happened without the Cold War. Because when Sputnik was launched into orbit on October 4th, 1957 by the Soviets, the Americans created NASA to outdo the Soviets. In fact, technology from the Intercontinental Ballistic Missile, a nuclear weapon, was reused by NASA for the Apollo 11 moon landing in 1969. This shows how the atomic bomb is a good invention, by indirectly leading to one of mankind's greatest achievements, landing on the moon. So, in a conclusionary statement, I believe that the atomic bomb is one of humanity's greatest inventions, as it has contributed to humanity eventually landing on the moon and forced world leaders to be more careful and cooperate more with each other, as to avoid having to use a nuclear weapon for war ever again. The atomic bomb can therefore also be compared to the Gatling gun, as both were created as a form of deterrence, except the nuke was successful at doing this by being the ultimate form of deterrence, where both sides and everyone else not involved gets destroyed. But at the same time, that is the biggest problem with the atomic bomb, as the Cuban Missile Crisis has shown that humanity can get very close to the end of the world, because if we aren't careful with controlling the atomic bomb and ourselves, the word tomorrow will cease to exist. 10. Peace can only be achieved through war, and that if we choose to fight more wars, then we kill less people than last time.
We have a liftoff, 32 minutes past the hour.